Hello, Mastery P&ID and other schematics. Practical approaches for complete beginners, self-learning on how to examine, interpret, draft P&ID and other schematics diagrams. Today we shall be looking at Chapter 5, Lesson 1, Component of Process Control Loop and Symbols. What is a control loop? Control loops are used in various industrial designs to sustain process variable set point or values and to ensure the stability of continuous control system with minimal or without error or deviation from the target values. Control loop can be open or closed, or sometimes a customized loop. Typically, control loop arrangement may contain one or more of the following elements, depending on the loop: open or closed or customized. Sensor, transducer, converter, transmitter, indicator, recorder, control, and final control element. Generally, 5 basic components can be used to define a control loop: the input, process-based control, the output, the sensor elements, and the controller, and the actuator devices. For illustration purpose, a typical control loop arrangement can be: we have the physical variable coming in, we have the sensor or the transducers, then we have the transmitter, okay, then we have the controller, then we have a typical final control element, which can be an actuator or otherwise. On this note, let's look at primary element or sensors. Sensor or primary element can be digital or analog type devices, which measure the physical change in the system and capture the result of the process variable. Examples of some analog sensors can be thermocouples, thermostat, remote terminal detector (RTD) for temperatures measurement. We have the strain gauge, the pressure sensing diaphragm. We have the capacity cell for pressure measurement, the orific plate, pit-top tube, magnetic flow tube for flow measurement. Examples of some digital sensors: limit switch, optical sensor, proximity sensor, photoelectric sensor, and so on. Figure I to VII show the graphic and symbol of some controls elements. Transducers. A transducer, also referred sometimes as sensor, are devices which convert energy from one form to another. Transducers convert a physical variable, which is a field variable, into electrical signals. Transducers are also referred to as pickup, or example RTD. This is the graphic representation of a remote terminal detector RTD, and this is the standard symbol, the P&ID symbol of RTD. The transmitters. Transmitters, also referred as converter, are devices that convert signal into a standard signal of 4 to 20 milliamp or 0 to 10 volt that can communicate through the controller. Example are pressure transmitter, flow transmitter, temperature transmitter, level transmitter, analytic transmitter, and so on. This is a graphic representation of a transmitter, and the P&ID symbol for a transmitter is this: signals. Signals are used to transmit process variable into and out of a controller or a control system. Signal can be input or output. Input is an excitation signal which is provided through an external sources as a result of disturbances of the system. Output. The overall effect of the system after the input excitation signal is referred to as the output. Disturbances. Disturbances is an instability in the input signal which causes a system to fail to produce the desired output. Internal disturbances, where the source of instability is generated within the system. External disturbances, where the source of instability is generated from outside the systems. Signal can be digital, analog, or pneumatic, and so on. A pneumatic signal. The pneumatic transmitter uses air or gas as pressure to control an output medium, which is directly proportional to the process variable being examined. The standard pneumatic pressure signal in the industry is in the range of 3 to 15 psi. Analog signal. An analog signal is a kind of signal that is continually varied. We have the digital signal. Digital signals express variation in the system variable in response to a set of discrete values, 0 or 1, on or off. Indicator. An indicator is a device that displays the value of process variable or status of the process. Indicator can be analog, such as pressure gauge, temperature gauge. A digital indicator displays the status of the process as digital, such as a digital timer indicator. Recorder. Recorders are used in industry to provide historical or changes during operation by recording the changes and comparing the report over time with the result of the operational progression or expected result. Examples of recorder instruments are electrocardiographs, video camera, weather monitoring devices, pedometer and fitness tracker, thermoscope, graphic temperature meter, and so on. Controllers. Controllers are the unit which store program for the control process plant or system. It receives input signal, process the signals, compare with the set point, and send an output signal to achieve the desirable result. Controller can be a DCS, distributed control system, PLC, Programmable Logic Controller, RTU, remote terminal unit, and I&D, intelligent electronic devices, and so on. Programmable Logic Controller, PSA. A Programmable Logic Controller, PSA, is an industrial computer used to automate process plant by performing the logic, instruction, and function, which is executed by electrical hardware. The figure 5.2.1 shows a block diagram of a typical PLC. Here we have the power supply to the PLC. We have the CPU, the central processing unit, which houses the memory and programs data. Then we have the programming devices. Then we have the input and the output module. Distributed control system, DCS. DCS is a kind of automation system which provides centralized distribution operation for interacting process. We have a block diagram of distributed control system here. Here we have the CPU, the digital input module, the analog input module. Then we have digital output module, the analog output module. Here we have the converter devices. We have the power supply, the isolators, and the feed and terminators. So this is not the detailed description of the distributed control system. This block diagram is for illustration purpose. Next, we have intelligent electronic devices, IED. Intelligent electronic device is a controller whose function involves the transfer of data or control signal across control sensor and other electronic devices. Here again, we have a typical block diagram of IED. Here we have the auxiliary power supply, the analog input, the digital input, the analog output, digital output, and the serial communication. The remote terminal unit. Remote terminal unit is a microprocessor electronic devices controller that integrates control sensors to control connected systems through remote transmission to and from the system. Here we have a block representation of the ROTD. For illustration purpose, this is not a detailed description of ROTD. We have the power supply, the CPU, the memory, the communication module, the digital input, digital output, the analog input, the analog output, then the feed devices and the ICO, which and the other controller that are interfacing with the ROTU, which could be IED. Then we have the control bus, the modem for remote control, final control element. Final control elements are devices that cause physical changes to achieve our desired output. Example, actuators. For a control valve, the valve sync device is actuated to achieve the set point when there is impact of disturbances. For a heater, it is the heating coil device that actuates. An actuator can be controlled pneumatically, hydraulically, or electronically. Examples: final control devices of flow control system, pumps and control valve. Final control devices of temperature control system, heaters and boiler, and so on. Control devices of pressure control system, compressor and valve. A typical graphic illustration of a control valve. Next, we are looking at instrumentation classification. In a control system, instrument can be classified as primary, secondary, auxiliary, or accessory for assigning loop identity and symbols. Primary instrumentation. Primary instrumentation are mostly instruments that respond to signal or devices that are programmable, such as transmitter, recorders, controller, control valve, self-actuated, safety and control devices. Secondary instrumentation. Secondary instrumentation consists of instruments that measure monitor or control devices and hardware or feed signal such as level gauge, pressure gauge, thermometer, and pressure regulators and others. Auxiliary instrumentation. Auxiliary instrumentation are mostly instruments or hardware that work with primary or secondary instruments. The figure here represents the graphic illustration of auxiliary instrumentations. Accessory instrumentation. Accessory instrumentation are instruments or hardware used for visualizing the result of operation of the measure, monitor, or control variables. However, the figures displayed above are for illustration purpose, and they are just for graphic representation of the elements as defined. Next, we are looking at process loop arrangement. A process loop arrangement is the combination of various components linked together as a unit to direct or regulate process system. The figure herein is an illustration of a process loop arrangement. Here we have the physical variable coming from the feed. We have the sensors that will sense it. Then we have the transmitter, if need be, that will convert it. Then we have the controller that will process it. We have the final control element. In process control, a transmitter receives the signal from the sensors. The common standard can be electrical signal of 0 to 10 volt or 4 to 20 milliamp. It can be pneumatic signal of 3 to 15 psi. For example, most transmitters are rated in DC current or DC voltage of 4 to 20 milliamp or 0 to 10 volt. In reality, for a temperature feed value of 0 to 200 Fahrenheit of true feed value, the transmitter output will calculate the percentage interpolation to as 0 to 100% of the physical variable. In this system, the 0 here, which is the feed value, represents 0%, and the 200 degree Fahrenheit represents 100%. The transmitter or the converter here, if the DC current is applicable, the 0 here represents 4 milliamp, and the 100% here represents 20 milliamp. If the transmitter signal is rated in voltage, here the 0 here represents 0, and the 100% here represents 10 volts. So for 200 Fahrenheit, the transmitter will send 10 volts or 20 milliamp. For 0 Fahrenheit, the transmitter will send 0 volt or 4 milliamp. As discussed before, a control loop can either be feed forward, which is the open loop, or feedback, which is the closed loop. For the feed forward control system, open loop. The feed forward or open loop control is a system where the output is independent on the input signal. It is useful in an application in which no feedback and error handling are necessary, as it measures one or more input of process, calculate the required value of the other input, and then adjust the variable to predict the output. The figure here represents a block diagram of an open loop feedback control system or closed loop. A feedback control system is a system where the output depends on the input signal. When there is deviation from the expected result, the system generates error signal, which is the main difference between the output and the input of the system. A typical closed loop system, as illustrated here, we have the system here. Then we have the input, which are both the feed A and feed B. We have the output coming out from the top, and then we have another input again going to the system, okay, the steam. Then we have another output coming down from the buttons. In this content, I leave you here with some quick exercise. Thank you. See you again in lecture 6.